In this lecture, we discuss conditional probability further. We take some simple examples to understand and illustrate the concepts that we learnt in the earlier lecture. So, we begin with some match the following questions, so that we understand the concepts. There are 5 items given in column A and 5 items given in column B. So, probability of B given A, probability of B complement given A, Bayes rule, multiplication rule and independent events. Probability of B given A is P of A and B divided by P of A is the equation that we saw in the earlier lecture. So, that is the answer. Probability of B complement given A is relatively easy, that is 1 minus probability of B given A, which is shown as 2 here. The earlier one was shown as 1 here. Bayes rule, different forms. So, one of the equations is P of A given B is equal to P of B given A into P of A by P of B, which is given, which is Bayes rule from here. Multiplication rule is 4 P of A and B is equal to P of A into P of B given A, and independent events P of A is equal to P of A given B, because A and B are independent, and therefore P of A is P of A given B. Next, we look at some true or false questions. Now, the course instructor wants to find out reasons for absence in class. So, let A be the event that the student is absent and B is an event that the student is sick. So, probability that a student is absent is higher than the probability that the student is absent given she is sick. So, the answer is false, because generally absence could involve other reasons other than sickness, and because we restrict it to a reason that is sickness, so probability of the person is absent given that the person is sick will be much higher than the probability that the student is absent considering other things other than sickness. Therefore, the answer is false. Probability that the student is sick when it is known that she is absent is equal to the probability that she is absent given that she is sick. This is comparing P of A given B and P of B given A, and we have already seen that P of A given B is not equal to P of B given A, and therefore, the answer to this question is a false. If P of A, that is P of absent, is 0.15 and P of sick, P of S is 0.1, then we can find P of S given A. We need to know P of A and S, which is not given, and therefore, we cannot find the probability of P of sick given absent with the data that is being provided. So, we also want to check whether some of these are independent or dependent. So, recording the manufacturer of a sequence of cars in a highway are not dependent so much on each other. So, they could become, the sequence of cars can be independent. Recording the age of a person coming out of a movie theater, again we could generalize it by saying independent, though one might argue that there is a larger proportion of people belonging to a certain age bracket who would go for movies. But by and large, if we assume that people of any age group go to a movie, then it is independent. Tracking the number of visits to a video available in the internet can be dependent, that would depend on an earlier visit and so on. Amount purchased by different people in a supermarket does not depend, so it is independent. Recording the type of accident during rainy season by an insurance company. So, the moment there is a rainy season, you could have more accidents that come out of skidding, it would come out of other rain related things. So, there is a dependence in the whole process. So, look at a few more questions. One question is, it is observed that half the tape recorders have a flaw, and such tape recorders would die within 6 months if they had a flaw. Die meaning they would stop working within 6 months if they had a flaw. Out of those that do not have a flaw, 10% would anyway stop working within 6 months. Now, your tape recorder died in 4 months, which means that it stopped working in 4 months. What is the probability that it had the flaw? So, now you want to use the Bayes equation. So, probability that it died or it did not work given that it had a flaw is given by this equation. So, 0.5 into 1 by 0.5 into 1 by, because this 1 comes because if they have a flaw with a 0.5, it will anyway die within 6 months. So, since it died within 4 months, 0.5 into 1 plus 0.5 into 1 plus 0.5 into 0.1. So, you get 0.5 divided by 0.5 into 1.1. So, 91% that it had the flaw. Out of 10 items that has arrived, 1 is defective. A worker picks these parts one by one. What is the probability that the first is defective and the second is defective given that the first is not defective? So, the first is defective, probability of defective is 0.1. So, and there are 10. So, you pick any one randomly, and 1 by 1 implies you picked randomly, and 0.1. Given that the first is not, what is the probability that it is? So, it is 1 by 9 because the first one is not defective. So, there are 9 remaining parts, out of which 1 is defective, and therefore, it is 1 by 9 and it is 0.11. Now, we look at one more question. You are travelling by air from city A to city B with the stopover at C. The probability that your flight arrives in time in the intermediate airport is 0.9, and if it arrives in time, the probability that your luggage makes it to the flight from C to B is 0.95. If the flight is late in the intermediate, then the probability of luggage making it is 0.6. What is the probability that your luggage comes to B when you reach B? And if your baggage is not there when you reach B, what is the probability that you arrived late at C, which is the intermediate place? So, question number 1, probability that your luggage comes to B when you reach B is reaching C in time and luggage going from C to B, and reaching C late into probability of luggage going from C to B. So, reaching C in time is 0.9 and luggage going is 0.95. So, reaching late is 0.1 and luggage going is 0.6. So, 0.9 into 0.95 plus 0.1 into 0.6, which is 0.915. Second, if your baggage is not there when you reach your destination B, what is the probability that you arrived late in the intermediate one C? So, the general equation is given here, which is now expanded to probability given that there is no luggage, what is the probability that you arrived in C later. So, probability of arriving in C late given that there is no luggage when we reached B is probability of no luggage given late into probability of late divided by probability of no luggage given late into probability of late plus probability of no luggage given in time into probability of in time. So, probability of no luggage given late is 0.4 because probability given late no luggage 1 minus 0.6, which is 0.4. Probability of late is 0.1 because arrival is 0.9. So, 0.4 into 0.1 plus same 0.4 into 0.1 comes here plus 0.05 into 0.9. So, probability of in time is 0.9, which is here, and then 0.95% is when it goes. So, 0.05 is the probability that it goes late, the luggage does not come. So, 0.05 into 0.9, so 0.04 by 0.085, which is 0.47. In a colony, it is observed that 82% of the people have internet at home. It is also known that 76% have computers, and out of these 11% do not have internet. Treating proportions as probabilities, find the probability that among the houses not connected to the internet, how many do not have a computer. So, we could assume or say without any loss of generality that there are 100 houses. So, there are 100 houses, which is shown here, which is 100. 82% have internet. So, we create this table with computer, without computer, with internet, without internet. So, the total here with internet is 82, therefore, without internet is 18. 76% have computers. So, with computers, total for computer is 76, total without computer is 24. So, 11% do not have internet. So, with computer without internet is 11% of 76, which is 8.36, and therefore, we can fill the rest of the table 67.34, 14.36 and so on. So, without computer and without internet is 9.64. So, probability is 9.64 by 18 and 0.5356 is the answer. So, with this we finish our discussion on some aspects of probability as well as conditional probability. Now we move to the next topic in probability, which is random variables, and we will spend some time on understanding random variables, and then we will work out some examples to further our understanding. Now let us start by saying sale in a shop today is 10,000. The shop owner expects the same sale tomorrow with a probability of 70%. It can be 12,000 with a probability of 12% or 9,000 with a probability of 18%. So now we have the sale in a shop as a variable, and this variable according to the sentence or text given can take 3 values, which is 10,000, 12,000 and 9,000 with probabilities 70%, 12% and 18%, adding up to 100%. Again, proportions and probabilities are used interchangeably, so probability is expressed as a percentage. So in this example, the sale or change in sale, as the case may be, is the random variable. So here is a variable which can take multiple values with defined probabilities, so it becomes a random variable. So it describes the probability of an uncertain future numerical outcome of a random process. So conventionally, capital X or uppercase X is used to represent a random variable. X does not represent a single number, but represents a collection of possibilities and the probabilities associated with them. So in this case, change X is the variable we are looking at. So increase is plus 2000 is a change with probability 0.12. If it remains the same, 0 with probability of 0.7, and if it decreases, it is minus 1000 with a probability of 0.18. Note that the notation capital X equal to small x means that the random variable x uppercase takes a possible value of small x given by the lowercase. So probability distribution of a random variable is given by P of x equal to P of x equal to x, where in x equal to x the uppercase x is the random variable and the lowercase x is the value that the random variable can take, or a possibility that the random variable can take. A cycle shop sells 4 types of cycles A to D, and these cost 2,500, 4,000, 6,000 and 8,000 respectively. Out of the people who buy, 60% buy A, 25% buy B, 12% buy C. So 60 plus 25 is 85 plus 12 is 97. So what is P of y equal to D is 3%, because the proportions add up to 1. So 60 plus 25 85, 85 plus 12 97 and 3%. What is the probability that cycle costing 4,000 is bought? So you could have 4,000, 6,000 and 8,000, which is 25 plus 12 plus 3, so 40% or 0.4, which is also equal to 1 minus less than 4,000, so 1 minus 0.6. Now what are some properties of random variables? A random variable conveys information that resembles what we may observe in a histogram. We take data for 50 days and let us say the sale was the same in 35 instances. The sale increased by 2000 in 6 instances, decreased by 1000 in 9 instances from the base value. So x bar, the expected value of the change in sale, is minus 1000 into 9 times, because it decreased by 1000 in 9 instances, plus 0 into 35 times, there was no change 35 out of 50 times, plus 2000 increase, so 2006 times divided by 50, which becomes 60. So mu of the random variable is the weighted average of the possible outcomes and their probabilities. So the expected value, one could use x bar equal to 60, but then we generalize that mu equal to 60, which is the mean of the random variable. Now what is the difference between x bar and mu? X bar is a statistic computed from the data, while mu is a parameter. Parameters are represented using Greek letters. So mu is equal to x1 into p of x1 plus x2 into p of x2 plus etc. So mu tells us that on an average the sale can increase at 60 per day. Mu is also known as expected value of x, so E of x is mu. So also note that the expected value need not take any of the values of the possible outcomes, and it can be an entirely new number. So another exercise: to increase popularity, a TV show announces a prize money of 50,000 daily and asks 5 questions. They pick only one caller for a question and the money is distributed equally to the callers with the correct answer. The probabilities of number of winners are 0.05, 0.15, 0.25, 0.3 and 0.25 for the 5 questions respectively. Mu is equal to 1 into 0.05 plus 2 into 0.15 plus 3 into 0.25 plus 4 into 0.3 plus 5 into 0.25, which is 3.55. Expected money is 50,000 by 3.55, which is 14,085. They pick only one caller for a question and the money is distributed equally to the callers with the correct answer. So, the probabilities of the number of winners are 0.05, 0.15, 0.25, 0.3 and 0.25. Now, this means that there are 5 people who are called, one for each question. Now, this 0.05 means out of these 5 people only one answered it correctly. This 0.15 means out of the 5 people 2 answered it correctly, and if 3 answered correctly the probability is 0.25 and so on. Therefore, the expected number of people who answered it correctly is 3.55 and therefore expected money per person giving the correct answer is 14,085. Now, if we say that on this day only one person gave the correct answer, so that person gets 50,000, 1 out of the 5 gave the correct answer, so the person gets 50,000 and that happens with a probability of 0.05. 2 people gave the correct answer, then the money per person is 25,000, that happens with 0.15 and so on. And if we now find the expected value, it is 16,666.75 versus 14,085. So, expected value of money 1 is higher than the total money by the expected number of winners. So, it depends on how you calculate and what is the expected value we are trying to calculate. Now, let us also try to understand variance and standard deviation. Just because mu is positive, the sale does not increase, though on an average it is expected to. For example, a lucky draw may have a positive mu, but not all the people make money all the time. So, variance and standard deviation of a random variable summarizes the uncertainty among the outcomes. So, variance is the expected value of the squared deviation from mu. So, sigma square is equal to variance of x is equal to expected value of x minus mu the whole square, which is x1 minus mu the whole square into probability of x1 plus x2 minus mu the whole square into probability of x2 and so on. To compute the variance of a random variable, we revisit the example, the sale example, where change in sale x is the random variable, and we have seen that this random variable takes 3 values, 2000 plus 2000, 0 and minus 1000 with probabilities 0.12, 0.7 and 0.18. We also note that these probabilities add to 1. Now, the expected value of this random variable is 2000 into 0.12 plus 0 into 0.7 minus 1000 into 0.18. 2000 into 0.12 is 240, 0 into 0.7 is 0, minus 1000 into 0.18 is 180 minus 180, and therefore, the expected value is 240 minus 180, which is 60, which is shown here as mu equal to 60. Now, to compute the variance and standard deviation, we first find out the deviation, which is x minus mu. So, 2000 minus 60 is 1940, 0 minus 60 is minus 60, minus 1000 minus 60 is minus 1060. X minus mu square values are shown here for the 3, and the variance is sigma x minus mu the whole square into p of x, which is 3763600 into 0.12 plus 3600 into 0.7 plus 112360 into 0.18, which adds up to 653880. In this variance computation, we do not have a divided by n, which normally we saw when we did this in statistics. The reason being the sum of the probabilities add up to 1, and therefore we do not have to divide it by n. So, sigma square is calculated as 653880, which is the variance, and standard deviation is the square root of its variance. We take the positive square root and we get 808.628. So, this is how we calculate the expected value or mean and the standard deviation of a random variable. Another example, a customer had ordered 2 engines and the profit per engine is 20,000. There are 10 new engines in stock, and by mistake 2 used engines are mixed with the 10 new engines. If the customer gets a used engine, then it can be replaced with a shipping cost of 1000. If for some reason both the engines sent happen to be used engines, then the order will be cancelled and the shipping cost for 2 engines is incurred. Now, how do we model this? Now, we have new engine and used engine for the first, and new engine for and used engine for the second. Now, there are 10 new engines in stock, and by mistake 2 used engines are mixed with the 10 new engines. Now, there are 12 engines, out of which 10 are new and 2 are used. So, the first engine, assume is picked randomly. A new engine would be picked with a probability 5 by 6, and a used engine would be picked with a probability 1 by 6. Now, the second one, if the first one was a new engine, then out of the 10 new engine 1 has already been picked and 11 are remaining. So, another new engine would be 9 by 11 and a used engine would be 2 by 11. And in the first instance, if we had by mistake picked a used engine, then the second one picking a new engine is 10 by 11 and picking another used engine is 1 by 11, and therefore, the probabilities are 15 by 22, 5 by 33, 5 by 33 and 1 by 66, and let us just check if they add up to 1. So, 15 by 22 is 45 by 66, 5 by 33 is 10 by 66. So, 45 plus 10 55 plus another 10 65 plus 1, so 66 by 66. Now, what happens if for some reason both happen to be used engines, then the gain is 40,000, because one used engine it can be replaced, 2 used engines the order will be cancelled and the shipping cost for 2 engines is incurred. So, if both are new engines, there is no issue. So, 20,000 plus 20,000, 40,000 is the gain, and that happens with a probability of 15 by 22. So, 15 by 22 is 0.682. If one engine is a used engine and one is a new engine, the gain is 20,000, the other one has to be taken back and a shipping cost of 1000 is incurred. So, the actual gain is 19,000, and that happens with the probability of 1 new 1 used is 5 by 33, 1 used 1 new is 5 by 33. So, it is 10 by 33, which is about 0.303, and if both happen to be used, then there is no, both has to be recalled. So, 0, and then there is a 2000 shipping cost. So, it becomes minus 2000, and now the average is 40,000 into 0.682 plus 19,000 into 0.303 minus 2000 into 0.015, which is 33,007. Now, x minus mu is calculated, 40,000 minus 33,007, 19,000 minus 2000 minus 33 squared multiplied, variance is 1,111,80951 and standard deviation is 10544.24. So, though the expected value is high 33,007, the high standard deviation indicates that in this case there can even be a loss, however small the probability of that loss is. So, we finish or conclude this lecture at this point, where we defined a random variable and then we also said it can take values. We defined a notation x, capital X equal to small x, where capital X is the random variable and small x is the value, and then we defined the mean or the expected value. So, we said the gain or outcome multiplied by the probability. We also defined the variance and standard deviation, So, we find the expected value and then we do x minus mu and then we do x minus mu the whole square multiplied by the probability and then we sum it up to get the variance and then the square root of the variance is the standard deviation. So, we looked at all this. So, we defined the what is a random variable and then how to calculate its mean and standard deviation. So, we will also look at some properties of random variables and answer some simple questions like what happens if, for example, we add or subtract a constant and so on. So, we look at all of these, what happens to the variance when we multiply by a constant. So, all these things we will look at in the next lecture.